Hello and welcome back to Farmyard Academy. So we've got another video here for you today. We're looking at trying to balance complicated redox half equations. If you've not watched the first video, definitely suggest that you should do that first, because that sets the scene. So that's a revision clip. Links in the description. But yeah, so pause the video, have a go at the equation at the top, see if you can follow the rules and the strategies to balance it. Okay, once you've had a go, we'll get straight on with it. So first thing that we're going to do is we're going to write out the equation, and we're going to go straight into strategy 1, which is put the oxidation states in. So if we follow our rules, we'll see that oxygen is always -2 in a compound unless it's in hydrogen peroxide. Because we've got 4 oxygens, we have to multiply the -2 by 4, and that will give us -8. Now, because the sulfate ion has an overall charge of 2-, that -8 must be reduced down, or reduced in number terms to 2-. So in order to do that, the sulfur has to be +6, because +6, 8- makes 2-. Then we'll do the same on the right hand side with the sulfur dioxide, and as you can see, we've got 2 oxygens this time, so it's -2 multiplied by 2, which equals -4. Now there's no overall charge associated with the sulfur dioxide, so that must mean that the sulfur dioxide is 0, which means in order to get the -4 to 0, we must have a +4. Okay. And then what we've got there is we've got oxidation states of oxygen, which stay the same, but the sulfur is actually changing. So we're going to highlight the sulfur's oxidation state, and then what I'd advise to do is just to get rid of, when you're practicing these at least, any other information that hasn't changed, so that you're not confusing yourself with more numbers. So now it becomes nice and straightforward to do stage 2, because we've got to add the electrons. Just to show you here, if I've got to go from +6 charge to +4, I've become less positive, so I must have gained negativity, and if I've gained negativity, it must be on the left hand side. So when I'm adding my electrons, I've got to add my electrons to the left hand side. So in order to go from +6 to +4, I must have gained 2 electrons, like that. Again, once you've done that, I would suggest getting rid of anything that you don't need anymore. We don't need the sulfur oxidation states, and we can move on to stage 3, which is to add H+. In order to add H+, we need to work out the overall charges on both sides of the equation. The sulfate ion's 2-, and you've got 2 electrons, which makes an overall charge of -4 on the left hand side. Sulfur dioxide is still 0, so we can put a 0 for the right hand side. When we're adding H+, you can see that H+ has a positive charge, and we need to reduce the -4 to 0. In order to do that, we have to add 4 H+'s like this to the left hand side of the equation. And again, once you've done that, get rid of information working out that's helped you do that. Okay, so that's what we've got. We're still not balanced yet, so we need to move on to stage 4, and this time we've got to add water. If I put 4 H+'s on this side of the equation, in order to balance those H+'s, I need 2 waters on the right hand side. Okay, because 2 times 4 hydrogens makes 2 times 2 hydrogens makes 4, and then we're all balanced. And by doing that, if you went through it in turn, you'd see that that equation now is completely balanced. Okay, so hopefully that's helped you. And as I say, keep practicing, follow the strategy, and you can't go far wrong. So yep, see you on the next one.